Hi, hello everyone, and welcome back. So today we're going to be creating a project known as an EcoSense, which is a smart environment monitoring system. So the idea behind this project is to learning outcomes basically is to read multiple sensor inputs, right? We're going to be using different input sensors today, and it's basically to help monitor your environment, understand the difference between analog and digital signals, apply decision making basically, right? So for today's project, we're going to just be needing just very few components and very necessary important components. And the components required is the first one, which is the Arduino Uno, which you already have right here. Another component that we need is very important is the LDR, which is also known as the photoresistor, or yes, it is a photoresistor right here, or the light density resistor. This sensor helps to detect light. It senses light in the environment. So you can actually use it to monitor your office, how if the office is dark, or if it is light, if there's light in the office, or you just want to use it to safeguard basically. It's just a very basic project. Another that you need is a potentiometer. This helps you to check the threshold. You know, when you have like this volume that reduces and increases volume. So yes, this is where potentiometer is going to help us to reduce the threshold, the density of the light. That's basically what the potentiometer, why we have a potentiometer right there. Now for this project, we actually need three LED, one for red, one for yellow, one for green. So just like a traffic light that says, the yellow says stop, the green says go, the yellow says wait, the yellow says go, wait, and the red says stop. So this is just the way we're going to do this. So that's basically it. So in this case, the yellow is going to be like, okay, it's a mode. Just start preparing yourself, start checking the environment. The green is, oh, it's a stable environment, nothing is happening. Density of the light is good. And the red, oh, there's danger, there's darkness in the environment, and all that. So we have an intruder. It depends on what you want to achieve with this project, basically. Then, of course, we have our buzzer that would help us to emit sound. And the buzzer right here, it's a passive buzzer, basically. It doesn't it's a passive buzzer. You can, and it's very good. You can actually use it for to create music, basically. Yes, to create music, right? So we need resistors. I always advise everyone, whenever you're dealing with using LEDs, please add your resistors. Very important. So I'm going to be adding my three resistors, and they're going to be 220 ohms. Every resistor has its unique color, so you would observe that this was a 1K resistor and the color is different, but once I change this to 220, the color changes. So this is it. So it's very important, noticeable, very important to note the resistor colors. So this is for, there's a difference. At this extreme end of this 1K, it's a brown, but here it's another color like a wine or gold. But yeah, this changes to 220 ohms. So yes, we have our third resistor. I would have added another resistor, which is a 10K resistor, but I like to add that for the LDR, because normally when you want to connect the LDR, it has two pins. So you connect the resistor to the AO and the AO to the GND, basically. So I'm going to add it, change this to 10K, basically. So we have a 10K resistor. So yes, these are just all the components that we need for today's project. So now it's time for us to do our proper connections, okay? So let us start. I usually like to start with the LED. So let's connect. The LED has two pins. One is positive, which is anode, and the other is negative, which is a cathode. This bent leg here is anode, this one here is cathode, just to create a balance. So I'm going to connect this right here to the resistor. I like to make neat connections. So I'm going to connect this to my resistor. This to my resistor. Is nothing as good as avoiding short circuits. Okay, so and the other end, so the red goes to digital pin 4 right here, and the yellow goes to digital pin 3. It's just like we're going to just make it easier for us. Digital pin 3, I like to follow a series. and the green goes to digital pin 2. So the green goes to digital pin 2. So this is neat and nice. So digital pin 2. Now this goes to GND. So let's just take this directly to GND, which is ground. And I'm going to change the color immediately to black. I like to have uniformity in color, so it's easier. So this goes to GND. Let's take this to GND. Let's have all of them and GND, this GND of this path. So let's do this black and this other one to GND as well. So this GND. It's so nice when you do very neat circuits. Okay, so GND. If I was using a breadboard, I'll be creating a place where I connect all GM, so it's still the same thing. All right, so now let's connect the potentiometer. Potentiometer also has its ground, so I'm going to connect the ground. Let's connect the ground of the potentiometer. The potentiometer makes everything easy. So yes, so the signal we connected to the analog pin, right? So it's going to be connected. I'm going to connect this to A1. I'm going to connect this to A1. So I'll change the colors so that we'll see that there's a difference between the colors of the analog pins and colors of the digital pins. So let's change this to yellow. And this goes to 5 volts basically for voltage. This is a 5 voltage, so this is done. Okay, so let's do the buzzer. Buzzer is very easy peasy lemon squeezy to GND basically. It has both sides as well. So this is going to GND. I'm taking it to GND. So I'm going to change this to this color, and this goes to. So let's make the buzzer. Let's switch to the top. Maybe we should use the top in 5. I mean, it goes very nice with what I want to do. So let's take this to GND digital pin 5. So yeah, so it's easy for me to remember. Oh, let's do this. Okay, so that is done. So now let's connect our AO will go to this resistor, and from this resistor to the analog pin, which is AO. So I'm going to change this color to yellow basically. So that's just shows the difference. Yeah, I like colorful things. So this now to GND. I have another GND here. And of course, it uses a 5 voltage as well. It's being powered by 5 voltage. 5 volt. So let's take this. So the colors are very important. It just helps. Okay, so yes, we're done. I'm actually done with this. Let me just zoom out so I'm done to fit. Yeah, so this is much better. So we're done with the circuit connection, yada. So now, so it's time for us to write our instructions, the Arduino instructions, basically. So let's come over here for Arduino code and instructions. So it's very good for the comments so people understand what you're doing. So I'll just comment, this is this project, and this project monitors environmental conditions using 2 sensors. Potentiometer is also a sensor on its own. Sensors. It has a light sensor and potentiometer. So the potentiometer basically stimulates temperature, air quality, humidity sensor. It's just stimulation. So the Arduino Uno will analyze both sensors and determine whether the environment is normal, warning, and critical. So the green is for normal, the yellow is for critical, the warning, and the red is for critical. Just like I explained, traffic lights, green says go, yellow says ready, red says stop. So this time around it's going to be normal, warning, and critical. So that's basically what we're doing. All right. So now before we continue, let's declare our pins. Let's define our pins. To define our pins, pins definition. So yes, let's define the pins. just to, we have connected, it's also good to let know that this is what it's connected to. So const int LDR pin equals to AO terminates. So potentiometer const int, I'm going to use sensor pin equals to A1. It's best to use camel casing when you're declaring or defining or declaring creating variables, basically, right? So for green LED, you remember green LED, we use digital pin 2. So this const means as a constant, so equals to 3 const int red LED equals to 4 const int was equals to 5. So that's following. It makes a lot of sense, right? So now let us go to our setup. We're going to set up. We're going to configure components. We're going to configure components right here. So to do that, we need our pin mode. So let output components, basically. Same with the button. So we're going to declare it as an output. So let's go pin mode red LED. It doesn't matter. Just okay. Let's just yellow is upset. Why do you want to skip me? Okay, so this is it. So let's go to red now. Red LED output. This is the buzzer. Pin mode. It's also an output device. So yes, I want things to show in my serial monitor. So I'm going to do serial.begin. So begin, and it's 968. That's the serial. Oh dear, sorry. I'm just doing this. Okay. So I wanted to write some sort of serial.print line. You know, printer is used to print, right? To display. That's the essence of printer. So it's basically the same thing. So I just put EcoSense environmental monitor, yada 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 yada. So you just see that. So now let's go to our main program. It's time for us to read the LDR value. So to read the LDR value, we're going to declare a variable. We're going to read LDR value. So let's declare a variable called int light value, because it's an analog here, so analog read. So what's going to be the reading is going to read the LDR pin, always terminate. So we'll terminate that. So now it's time for us to read potentiometer. So let's read potentiometer. So let me just go down. It's easier for me guys. Read potentiometer. So int sensor value equals analog read sensor pin. So let's display sensor values. So now let's display our sensor value. We're going to use a serial pin, serial.print, and we're going to declare this and say lights. And we're going to use a print sensor. Sensor. So serial dot print line. So what was this? We now display what the sensor value. So serial dot print line. Lights value. Okay. Alright, so like to space out. So now it's time to reset outputs. So we're not going to work with the digital pins right now. We're going to make everything low. Both the everything will be low. We're going to make everything low. So at this point, no digital rights, yellow LED, low. So no component would be turned on. So no tune buzzer. Okay, now let us test for normal conditions for when the green LED will turn off. So we're going to use if statement now. If our sensor value is less than 350, then what should happen? Then digital rights, the green LED will come up. So the green LED will come up. So we're going to make a print serial print line. We're going to make a print environment status. Environment status would be no. So in the case of warning, then we close that. So warning, that's when the warning condition, the yellow will come up. So is that else if, because it's not, well, we'll have another condition, else if the sensor value is greater than or equals to 350 and 2 and sign is for and is for less than 700. So what do we declare? Then digital rights yellow would come up. Digital rights yellow LED would come up, and the buzzer there'll be sound at the buzzer, but the emitting sound to be like low, not so high, but it just gives you then we'll have like a delay of let's say 150. Yes, so and then of course the buzzer will then stop emitting sound. It's because it's not supposed to be continuous. It just gives up first. It's warning alerts, warning you there's danger, prepare. So yeah, serial does print line. It's environment status would read warning. Okay. Else for critical conditions now. Critical conditions. Else digital rights LED will become very high, and there'll be continuous beeping of the, and to be very high. The buzzer will be very high, like 1.5. Like back. Okay, so and the delay will take a lot of time to delay, so the delay now in between would take a long time, so it's continuously beep before it will stop beeping, so that one will be at alert, right? So this is it. And the serial print line would be environment status critical status. critical. Critical. I'm supposed to write this in very capital letter. Critical. So what if now let us go to the parts where we detect light. Light detection. This time around we have used the value or sensor value. But next time around, let us now use lights. Let's deal with LDR. So if the light value is less than, then what should happen? Serial prints, room condition is dark because we were calculating with the threshold with the potentiometer. So now that it's not the potentiometer or the LDR itself, so serial print. So if it's not dark, so serial print, things are so case sensitive. Room condition, the room condition, right? So I just have my delay. Just make my delay. So this is it basically. So this is actually the end of the instructions. Nothing too serious. So like I said, so when the environment is safe, it will display the temperature normal, air quality good, just warning level and all that. So like I said, this is just an environment. It's just test an environment. So it's just used to monitor the environment, the lights, everything about the environment. It's just the lights, like eco sensing. So yes, now we're testing our simulation to see if this works. So hold on. Yes, so yeah, look at it. It's working right now. So let me just restart the simulation. So at this is a normal environment. Okay. So let us try. Once I tap, let's change the illumination and let's see if we'll have, let me just pause this. I want to zoom out more and fit so this we could see clearly. So now let's see. So now the environment is dark because the illumination I used the disk. Then you can see that the red is not showing, neither is the yellow showing because it's not critical condition. It's still a normal condition. So now let's try and change. Did you see that? I just changed this and it's a critical condition. What if I rotate to this part? It's a good condition. The threshold, so let's rotate. Did you see that? So this is a smart environment monitoring system. Hope you enjoyed this lecture. See you in the next class. Bye.